All right, this is notes 2-4, solving linear systems algebraically. We're going to look at a couple of different methods. One is substitution, one is elimination. Substitution is just like if you were at a restaurant and you were substituting one thing for another. It's the same thing here. We're going to substitute and replace one thing for another. First thing you want to look for is what can I solve for the easiest, x or y, and then you look for which equation, top or bottom, that would be the easiest to solve. Looking at the first one, x clearly is the easiest to solve for in the top, because if I just move one thing, I have just solved for x. So if in that particular one, I move the negative 2y across, now I have x equals 2y, positive 2y, plus 5. So I just solved for x. Now, x equals 2y plus 5, so 2y plus 5 equals x. They're the same, they're interchangeable. I'm going to plug that new x value in for x in the second equation. So it'll be 4, and then times 2y plus 5, close them, plus 3y equals 9. Now, a number touching parentheses. A number touching parentheses means multiply. 4 times 2y is 8y. 4 times 5 is 20. Plus 3y equals 9. Okay, now we want to solve for y. I've got my y's on the left side already. So 8y plus 3y equals 9. Take the 20 across, becomes a negative 20. So 8y plus 3y is 11y equals negative 11. Final step, I'm going to divide by 11, and y equals negative 1. So now in my solution set, I'm going to put negative 1 in for y, and I've solved half of it. Now I've got the negative 1 for y. I'm going to plug that back in for y and solve for x. So as we see here, I've already put it in x equals form up here. So if I plug that in, x equals 2 times my y, which was negative 1, plus 5, I can solve for x. X equals 2 times negative 1, which is negative 2, plus 5. So x would equal 3. I go ahead and put that in my solution set, and my answer is 3, comma, negative 1. That would be the coordinate, that would be the intersection, and solve that system of equations. I'm going to go ahead and skip to number 3 so that we can go ahead and solve it using the same method. We're going to use substitution. Looking at number 3, clearly y is the easiest to solve for because it's already by itself. I just got to move the 6x across. So I move the 6x across, and I have y equals negative 6x minus 5. So now I have a y value. I'm going to substitute it in for y in the second equation. So 4x minus 3 times my new y, which is negative 6x minus 5, equals a negative 7. I'm going to distribute that negative 3 through. So 4x, negative 3 times negative 6 is a positive 18x. Negative 3 times negative 5 is a positive 15, equals negative 7. X's are already on the left side of the equal sign. 4x plus 18x equals the negative 7 that was already waiting on me. 15 I take across, becomes a negative 15. So 4x plus 18x equals 22x equals negative 7 minus 15 is a negative 22. Now final step, divide by 22. And x would equal negative 1. Take that, put it in my solution set. So x is now negative 1. I'm going to go back to my y equals equation, plug that in. Y equals negative 6 times my new x, which is negative 1, minus 5. Y equals negative 6 times negative 1 is a positive 6, minus 5. So y equals 1, a positive 1. So the solution would be negative 1, 1. Okay, let's look at a different method. Number 2. It's elimination. Elimination means to eliminate. We want to eliminate one, x's or y's, and then solve for the other. So in order to eliminate, we have to have opposite. So if I had a 5, for instance, to eliminate a 5, I've got to go with a negative 5. A 5 minus a 5 is 0. If I had a negative 25, I've got to have a positive 25 to eliminate them. So looking at these, it doesn't matter which one I eliminate, the x's or the y's. Just we pick one and we're going to make it to where it is the opposite of its buddy. So in this case, it's easier to work with the bottom. So if, let's say I wanted to eliminate the x's. I have a 12x and a 3x. We go, what number is the smallest number 12 and 3 will go into? And the answer to that is 12. Well, the top one is already 12, so I don't have to do anything to that one. I would just rewrite it. 12x plus 8y equals negative 8. Now the bottom one, I need it to be a negative 12x. So I'm going to multiply it, everything on the bottom, by negative 4. Negative 4 times 3x would be negative 12x. Negative 4 times 4 is negative 16y. Negative 4 times 2 is negative 8. As we see, the 12's eliminate or cross out. 8y minus 16y is a negative 8y. Negative 8 and another negative 8 gives me negative 16. Finally, divide by negative 8. And y is 2. So I put that in my solution set. And I'm ready to plug that 2 back in to either equation for y and solve for x. So let's just stick with the bottom. 3x plus 4 times 2 equals 2. So that's 3x plus 8 equals 2. Subtract the 8. 3x equals a negative 6. Divide by 3. X equals negative 2. So our final answer, put that into my solution set, is negative 2, 2. Number 4, we're going to use elimination method again. Choosing whichever one does not matter. Let's say we choose the y's this time. I have a 3 and a 4. Smallest number 3 and 4 will both go into is 12. So I need one to be positive 12 and one to be negative 12. So let's go ahead and keep the top positive and the bottom negative. So I'm going to multiply the top by 4 and the bottom by a negative 3. That will get me what I want. 4 times 7x is 28x. 4 times 3y is that positive 12 we were talking about. 4 times 9 is 36. Now the bottom, 3 times 4x is a negative 12x. Negative 3 times 4y would be a negative 12 we were talking about. And negative 3 times a negative 4 would be a positive 12. As we see, the 12's cancel. 28 minus 12 is a positive 16. X equals 36 plus 12 is 48. Divide by 16. X would equal 3. Put that in our solution set. Take that x, plug it back in to either one. Okay, that value of 3 back in for x and solve for y. We can use the bottom one, is fine. So 4 times 3 plus 4y equals a negative 4. 4 times 3 is 12. plus 4y equals negative 4. Take that 12 across, so we minus 12. 4y equals negative 16. Divide by 4. And we get our final answer, which is y equals negative 4. Plug that back into our solution set. And we have our solution, which is 3, negative 4. On number 5, if we're using elimination, it doesn't matter which one. Let's say we eliminate the 3x, or the x's. 9 and 3, the smallest number they'll both go into is 9, so I don't have to mess with the top, so I just rewrite it. 9x plus 12y equals 3. The bottom I would multiply by a negative 3 because I need a negative 9. So negative 3 times 3x is negative 9x. Negative 3 times 4 is negative 12y. Negative 3 times negative 2 is a positive 6. And we see that our y's cancel off, but also problem is our x's cancel off. 0x plus 0y equals 9. Anytime I have both my x and my y canceling, but not the other number, that means that these lines, if I were to put them in y equals, they're parallel. Okay, so which means that if I graphed them, they would never ever cross. So this is no solution. It will never have an intersection. Something very similar on number 6. I choose which one I want to cancel off. It doesn't really matter. Let's say we do the y's this time. 20 and 4, the smallest number they'll both go into is 20. So I need one of them to be positive 20, one to be negative 20. The bottom is already set, so I just got to multiply the top. To get negative 4 to be a negative 20, I would multiply by a positive 5. So 5 times negative 2x is negative 10x. 5 times negative 4 is negative 20y. 5 times 2 is a positive 10. And I see that I have 0 x's. And the y's cancel off, so that's 0 y's. But also the number cancels off. Anytime they're all 0, that means if I put them in y equals and graphed it, the first one I would graph, the other line would be exactly the same, laying right on top of it, okay? Which is crossing at absolutely every point. So this one is infinite solutions. Okay, the work we're doing is a 2-4. We are doing number 1, 3, 6, 8, and 9. This concludes the notes for 2-4.